Welcome to the organic action, and the idea here is that we're going to do a preview, basically, of all of those things that are coming up as we get a little further into organic chem. So here's the idea. This is going to be a preview, and I want you to use this as an opportunity to get grades. So you're going to take notes on this, and it is for a grade. And the concept is this, that as I go through this, I'm going to present notes, but I'm not going to give you every item, but I will indicate where you're going to have the opportunity to include a few items of your own. Okay? So, for example, you will have a time when I will make sure that you know to fill something in, and I'll give you an itemized list of topics that you can add. Okay? Later on, I will compare your PDF or your picture of your notes. I'll compare your work to what we have on this original sheet. There will be times when I include, for example, perhaps a diagram, and then I would expect you to label that diagram based on what we're talking about in lecture. Okay? So this is a gradable item, and I'll show you how this works. That way you can gain some maximum points as we go through. Okay. Let's start here with the idea of general chemistry or general chem reactions. Okay? If you remember, in general chemistry we had 5 reaction types. You don't have to list all of them, but there were 5 reaction types. For example, we had synthesis and decomposition. We had single displacement and double displacement. And then we also had combustion. Okay? And I'm not really worried about the idea there of those specific reactions. But we also had the idea that it was very simple in the sense that usually that maybe you had 4 ions all at the same time, calcium and nitrate and sodium and phosphate, for example. So in that sense, it was simple compared to organic chem because you had simple structures that you're working with. Okay? So we had the 4 or 5 main types, and there's a tendency to probably think, well, if I have organic chem reactions, then certainly there should be some kind of parallel. Well, that's not really the case. There's some parallels, but not enough for you to go off on that. Okay? And there's a couple reasons for that. First of all, it's certainly true that organic chem reactions are certainly more complex. Okay? For example, we're dealing with very long carbon chains, right? And we're also dealing with structures that have very different properties based on small changes in the environment. And a small change in the environment can change an entire chemical reaction. But a lot of times we don't have that with organic or inorganic chem. So a lot of times organic chem is certainly more complex. You're going to see that with organic chem, you're going to have more steps. And by that I mean you're going to have the chemical reaction to go from reactants to products is going to involve a lot of processes. There's a lot of factors involved. And so sometimes you'll see 2, 3, 4 or more steps, and sometimes even longer. And so organic chem reactions are sometimes very complex. And finally, we talk about the properties. Okay? The properties of organic chem structures sometimes are very specific. For example, a slight change in the acid-base conditions or the addition of one atom to a carbon chain can change everything. And so sometimes very specific properties have a very big impact on the overall reaction in organic chem. Okay. If we talk about the reaction types, And these are a little bit more nebulous in some ways than you might see with the first year chem, or inorganic chem, if you will. But certainly, one of the reactions that you've seen before are called addition reactions. And you've seen that with, for example, with hydrogen. When we add H2, when we add diatomic hydrogen, when we add that to an alkane, we get an alkene, right? So you can add H2. Another time we might add HCl, right? So those two atoms just directly attached to an organic compound, and so we would call that an addition reaction. Another type of reaction is called a substitution. Now, a substitution reaction is just that one substance is removed from a carbon chain only to be replaced by another one. Okay? So a substitution reaction, I guess in some ways, is like a single displacement reaction, but much more complicated. Okay? There are two types of substitution reactions, and one is called an SN1, and then the other one is called an SN2. Now, we don't know much about what these numbers mean. We're going to explain that later. But there are two types of substitution reactions, and in some ways they're similar, and other ways they're very different. And these are going to take a long time to explain, so that's certainly a category of reaction. Okay? Another type of reaction in organic chem is called an elimination reaction. Now, an elimination reaction is just that a substance is going to lose a structure, for example, right? An elimination reaction, there are two types, so there's an E1 and an E2, okay? And so it has to do with the properties of something coming in, or not necessarily a substitution, however. So we'll talk more about those later. And finally, this category, a rearrangement. Now, in this case, a rearrangement might be a single bonded chain, for example, an alkane. Let's take hexane, for example. You've seen this one before. A six carbon chain will close in on itself, and it forms a ring, and then we call it cyclohexane, right? Same thing happens with sugars, that they will, in different environments, will adopt a ring shape or a closed shape, for example. So those are the types of organic reactions that we're going to talk about. What I'd like to do now, though, is talk a little bit more specifically about the substitution reactions. Okay. So for a substitution reaction, it is just that there's something being replaced. And I want to show you this concept here. There's the SN1 and the SN2. Now, sometimes you'll see it as this. Okay? So SN1 and SN2, they have specific meaning. So I want to take those apart. When we talk about S, right, that stands for substitution, which makes sense, that there's going to be a substitution taking place. The N stands for what is called nucleophilic, and that's reference to a nucleophile. And here's what happens, the concept that we are going to need to know, that a nucleophile is a positive region, or a positive species, if you will. And generally it's a carbon cation or a carbon cation. We'll talk more about that later. But a nucleophile is something that's looking for something positive. Now, the nucleo part means positive, and then the phile part means to like. For example, if you've seen the phrase hydrophilic and hydrophobic, right? You don't usually take those apart, but hydrophilic means it likes water, and it would be a hydrophile, if you will. But you don't usually hear that phrase. But nucleophilic things they like positive things. And by nature, then, a nucleophile is going to be negative, right? So a nucleophile, because it likes positive things, tends to be negative. It will be negative. Okay? And it's looking for either a full positive charge or a partial positive charge. And here's the thing about nucleophiles. Some examples would include methanol, right? Methanol, which is CH3OH. And I want to add to that, it's a nucleophile because it has these two unshared pairs. That makes it very negative. And so these are what are looking for the positives in the substrate that we'll talk about later. Okay. Another one would be ethanol, which is C2H5OH. Water. So ethanol and water. C2, but I want to draw those in because that's so important when we're talking about nucleophiles. And then water would be another example. We could also talk about acetic acid. That's a nucleophile. Okay. Let's talk about what these numbers mean in reference to SN1 and SN2 reactions. Before we do that, we have to talk about this concept called the rate law. And the idea of a rate law is that it's a mathematical expression, right? And I'm going to draw that here. A standard version of a rate law would be something like this. You could have this, and let's draw one more. Okay, all of those are actually rate laws. And really a rate law is just a mathematical expression. And AP Chem students have used this before. Some of the things to not worry about is the letter K, and that stands for rate constant. Okay. I do want you to know what it is, however. So the letter K stands for the rate constant. And really it's a mathematical way of converting molarity into molarity per second. So K is the rate constant. This stands for molarity, moles per liter. Okay, it's a standard way of referring to molarity in chemistry is to put brackets, not parentheses. In organic chem, though, you won't really see a molarity of a substance necessarily, but we use that concept still in organic chem as a reference to concentration. Okay? Now, this number up here, there's also this concept called the order, and that's really the power or the number that's used to show its effect on the overall rate. And we are going to talk about that right now. In fact, that's why we are covering this. Okay, let's go back to the concept of rate laws here. SN1 and SN2. The number 1 refers to the type of reaction that is what we call unimolecular. That means that there's one molecule that affects rate, right? Uni means one, and one molecule affects the rate of the reaction. And you'll find out later on that that has to do with, in SN1 reactions, it has everything to do with the leaving group. And we haven't talked about that yet either. But the idea of a leaving group is going to be very important. So in SN1 reactions, we can have more than one step. That's not really what this is about. But it means only one substance in that reaction affects the overall rate. Okay? And in SN1 reactions, that is from the leaving group. Okay? 2 then is bimolecular. And what that means is there are 2 substances that affect the reaction rate. There's 2 substances that affect the rate of the reaction. And we'll talk about that too. So both SN1 and SN2 reactions are complicated. And so one is not any easier than 2. and they are not in any specific order. You don't have to learn these first before you learn SN2 reactions. Okay, now let's go back to this idea of a leaving group, substrates, and nucleophiles, just to give you a general idea of what's going on with these types of chemical reactions. Okay, pardon me. So what's going on with a leaving group, a substrate, and a nucleophile? I'm going to draw one out for you. This is an SN1 reaction of sorts. It's not a complete one, and it's not going to show everything you need for later on. But if I draw this, this is a classic example of a substrate. This is what we call a tertiary, right? That's a tertiary carbon. It has 3 other carbons attached to the central carbon. Okay, it's also called an alkyl halide, and that's a standard thing in organic SN1 reactions. Is the alkyl, right? Alkane, single bond. Halide is Cl, and the idea is that this tertiary alkyl halide is attacked by what's called a nucleophile. So I'm going to draw a standard nucleophile here, like methanol. Okay, and you see this negative group is seeking, or will be seeking, this right here. It doesn't look like that. It doesn't look like it's positive at all, and that's why we're going to get into this later on. This chloride has to leave, and so that chloride is called the leaving group. That chloride leaves, and it will become a negative chloride ion. It takes the 2 electrons with it, and so generally what we do is we draw that the 2 electrons will jump onto that chlorine, and when it leaves it becomes a chloride. Now what happens is, I'm going to draw this. Let's draw this a little more carefully. We're not going to get too much into it, but now you have that positive right there. And that's called a carbocation, right? Carbon cation. Cations are positive, right? You should probably know that. A carbocation. And so what happens is we have this attack, and these negative electrons attack this positive situation there. The chloride has gone, and the overall reaction then is you'll have CH3, C, CH3, right? And this time we've made an ether. Okay? We're only going to do a little bit more on this, and then we're going to talk about, this CH3 here is from that nucleophile. Okay, so that's the general idea of nucleophiles and substrates. This nucleophile attacks this substrate here. This substrate has to lose this leaving group. This has to be stable. And then this nucleophile, after that chloride attacks, becomes positive. This negatively charged oxygen will come in there, attack, and then you're left with this. Okay, there's a lot of other chemistry that's going to go with that later on. Okay, there's some other concepts we have to talk about that I want to make sure we at least address. Okay, so we'll go down the list somewhat carefully, but quickly. The idea of chirality. That's going to be important. Okay, the idea of chirality is that some substances have what is called handedness, right? Your left hand and your right hand are not superimposable. You can't take your left hand, place it over your right hand in any way to make it identical. And so we have the sense of direction. So molecules have what is called handedness, or they have a direction to them. And part of the reason that's important is because it does affect how chemicals behave. It affects their properties. For example, when you have biological situations, some directions of molecules don't work and others do. And so we'll talk about that. So chirality during SN1 reactions, especially SN1 and SN2 reactions, the direction of the molecule actually changes its orientation. Okay? There are some other concepts here. For example, stability. That's not a topic that we talk about too much. Okay? But we're going to have to relate stability to what is called the substitution. Now, and here, substitution does not refer to those reactions that we just talked about, but the idea that when you have a carbon with 3 other carbons attached to it, you would call that a tertiary carbon. And sometimes this is more desirable in a chemical reaction. Let's put nothing over here. Sometimes this is more desirable for a chemical reaction, and sometimes it's less desirable. So you have tertiary, which would have 3 carbons attached. And of course, there's also secondary and primary. There's quaternary, which is 4. And so you designate it with this little degree sign. Okay? So stability is going to be something that we have to talk about later on. Another concept that's also very important, electron density. Now that is not something we have talked about in first year chem, but now with electron density, there's 3 ways that electrons can move around, and we have some very interesting concepts coming up. One is called hyperconjugation, and that has to do with what is called the overlap of orbitals. There's another concept called methyl shift. And now we're really getting into some organic chem. In a methyl group, well, we'll talk more about that later because it's too complex now. And then something called a hydride shift. And that is going to be where a hydrogen group actually moves over to somewhere else. We could also talk about the concept of resonance. Now, that's not necessarily it is kind of an electron density thing, so we're going to add that there. So these concepts are going to be important. Another important concept is going to be solvents. For example, the things that are meant to dissolve are also going to become nucleophiles. So you have a situation now where the substance used to dissolve, or at least be the environment for a chemical reaction, is also getting involved in the chemical reaction. And so sometimes you definitely need that. For example, you need acidic conditions, right? You might need an extra acidic condition to drive the reaction. We do that with aspirin. But on the other hand, you might need a basic condition, that the nucleophile, you need a basic condition to complete the reaction. And finally, we have the concept of mechanisms. And this is where all of this is leading. We can't talk much about mechanisms until we know the concepts we've talked about above. And there's probably more ideas. The idea of a mechanism is really is a spelled out explanation of where electrons and atoms and bonds move that get us from reactant to product. I'll say it again. Mechanisms are a detailed explanation of how reactants become products. A detailed list and an explanation, and it always involves a drawing. Okay? So mechanisms always involve a drawing. So you have to get used to drawing lots of structures very quickly. And then finally there's the concept of curved arrows. So all of those concepts. The idea of this assignment is that you can read all of these notes later, but the idea is that you take your notes here, and then we will have you fill them in. That'll be your grade, and I'll compare them to our notes later on. But the overall goal, besides that, is that let's look at all of the concepts that are needed to get us up and running for organic chem reactions.